Okay, now we are looking at the integration of exponential function. Okay, all right, here we go. Well, if we know, y'all, if we know that the ex exponential function, the derivative of e to the x is e to the x itself, then if you do the antiderivative of that, what did you get? Here we go. If you do the antiderivative of that guy, what did you get? If its derivative is ex itself. That's right. But what's missing? C. Perfect. Perfect. You see that? You know, the derivative of a function is itself. Therefore, the antiderivative of that is the function itself. But don't forget, remember, for example, if you have e to the x plus 3, okay, 3 is down here, and then you take derivative, what you get? E to the x plus what? 0. There we go. But then if you want to find the inverse of that, you have to add c, just to see that you have to be mindful of c, because when you are now dealing with integration, you have to know that a constant integrated give you 0. Okay. All right. Therefore, when you convert back and finding it, you have to be mindful of that c. Okay, so here we go. And that I am going to give you the definition and its rule, which is a very simple rule. And you will like it too. Here we go, guys. All right, we have e to the x dx. The integration of the integral of e to the x dx give you what? E to the x plus c. All right. If the exponent is just a single variable, that's what it is. What if now you deal with another big lump sum function, linear function, or whatever that is, e to the u, and u here is a function of x. Can anyone tell me what that is? Well, same thing, e to the u plus x itself. Ta-da! But you know what? It might be a little bit more than just e to the u when you integrate a function with a an exponential form in a big value. By that I meant this. Let's look at example. How about example 7? Okay, still we are at 5.4. Number 7, example 7, you have now e to the what? 3x plus 1 dx, and that's the exponent form right there. Okay, talk to me, y'all. Talk to me. We are dealing with, this is called indefinite. Okay, y'all? Indefinite integral. Looks like, yeah, indefinite integral. So look at this right here. I need to integrate e to the 3x plus 1. Do I use this e to the x formula, or do I use e to the u value formula? Of course, I see right now, this guy only deals with when x is just x itself. There is no exponent that is bigger than 1. There is no function on the numerator, on the exponent. So this right here, I need to convert this into that form right there. By what? By turning every x variable into u variable, so that I will have, I miss a very important right there, du. Okay, guys, du. There we go. Okay, just notice for you to see that right there. All right. Apply that right here. I am now going to convert, first of all, this function, this integral, into that form right there by what? Let u equals what? And you guys are very familiar with this. Let u equals, there we go, whatever that exponent is for e, 3x plus 1. Okay. Now, I also need to what? Convert dx into du as well. What do I do? If I let this one right here, if I define u is 3x plus 1, whatever I do on one side, I do to the other side, which is take d over dx of this right here, okay, over right there. So that equals what? What is this derivative of what? 3x is what? 3. Very good. Can I bring dx over here? This is a big notation that mathematician Leibniz developed and now we still use today. So that's right now du equals what? 3dx. Wow, is that so convenient for you? You see right here, 3x right now equals du. But over here you have only dx. I don't need 3. What do I do with 3? Adios, amigo. I'll let them move on the other side, okay? So I see I need to convert du in terms of dx, and I don't need 3. So I let 3 go on the other side. There we go. By that, now, ladies and gentlemen, I now have dx equals 1/3 of du, and the task is almost done for me. My purpose is to bring this into my formula and then just take it, execute that. Here we go. So this guy now turned into what? E, okay, e to the 3x plus 1, but since I let u equals that, so now, there we go. What is my du, guys? My du is what is my dx? My dx is 1/3, what? Du. There you go. Dx right here. 1/3 du. Plug it in. I rewrite this one to make it look really, really nice. So 1/3 e to the u du. Yep, I heard you. I saw that. I heard that. Yeah, I can bring 1/3 out, right? Very good. 1/3 out. There we go. E to the eu. There we go. It's a constant, so I can bring constant out, okay? But that constant being attached to eu as a product, not addition or subtraction. Therefore, I can do that, okay? Here we go. It's home run. Okay, all I do right now is just what? 1/3 times with what? Yep, time with e to the, you can do this right here. E to the u, but what's my u? My u is, look, one second at a time. My u is what? Here you go. U plus c. Okay, bracket. That's okay. Either way, parentheses. All right, but the problem asks us to integrate into x. So I plug x back in. Technically, the answer right now is 1/3. Look, I distributed this in. Okay, you see that? E to that give me e to the u. But u is what? 3x plus 1. And then 1/3 times c. Do I know c? No. So I got another c right there. Ladies and gentlemen, that is your solution right there. So this 5.4 is pretty yummy, and I'm hungry too. Are you hungry? So here we go. That's your solution right there on number example 7. I think we are ready for number 8, example 8. Shall we? Okay, would you look at example 8 with me, please? Example 8. Oh, I erased the formula. Guys, register that in your mind. Come on. I need some space. Okay, there we go. This is going fast, right? I will post your your homework on RenWeb for you. Example 8. You have right here is 5x e to the negative x squared dx. Okay, all right, we are asked to integrate and find the value for this integral right here. You look, Mr. Dan, come on, this is a big potato. Again, looks a little bit, strange because you got more complicated, but look, y'all, look one step at a time. We are math people, okay? So you see the pattern right here. Talk to me. Which formula you're going to use right here? Wow, you see that e to the negative x squared, it is not x itself, okay? Even negative x, you still need to consider e to the u du, and that is e to the u plus c. So be careful. This is the formula you're going to use right here, okay? Careful. Talk to me. What is your first thought that you would let u equal in this form? Correct. Let u equals what? Yep, negative x squared. Careful, okay? Negative x squared, and you will see powerful things coming out soon. Look at this. Since you define x equals negative x squared, take derivative both sides. D over dx of u, okay? That's right there. Negative 2x. Okay, got it? let u equals negative x squared. There we go. Because I need to use this formula. That's why. Then I need to convert dx into du so I can apply the formula. Now, can I bring dx over here? Yep. So I got right now du, okay? Over here is du. du equals negative 2x dx. Does anybody see something right here? Ha! Guys, look. I have x dx. I have x dx. And I don't care about 5 and negative 2 because those are constants. I can just bring them out. Okay? So here we go. Do you see what I see, guys? There we go. I see that, x dx, x dx. So I don't need negative 2, do I? Can I bring negative 2 over here? Indeed, you're right. Yep. Negative 2. I do the same thing both sides, okay? Negative 1 over 2. Let's notice negative, okay? So they both, technically, I just time with 1. There we go. So now what I have is just simply negative 1/2 du equals x dx. Ta-da! Why am I doing this? Because I am converting all the x values into u value, including the dx and the du. By doing that, look, my x dx is 1/2 of du. X dx is 1/2 of du. In a moment, you will see this. Shall we rewrite this right here? Can I bring 5 out, y'all? Just, that's constant, like a k. Bring it out. There we go. My x e to the negative. Look, I'm gonna do something that you will like too. Okay, I just reorder a product of two numbers, a times b equals b times a. Instead of writing x times e to the ex, can I do this? There we go. All right, just want to be careful. Now, look, this is right now very convenient for me. 5, my e to the, now I'm going to sub in with v, okay? Sub x for u term, okay? Not equivalent, but just x and into u term, okay? Just to spell it out for you. E to the negative x squared, what is that? Yep, u. There we go. You see it? There we go. You like the color? Here we go. What is x dx? X dx is